All right, welcome back, everybody. This is section 3.7, day one, kind of. It's kind of like all of it. Transformation. Now, what is a transformation? What even is this thing? What is a transformation? Well, just by going by definition, a transformation just describes a change. It just describes a change. How do you change from one thing to another? That's a transformation. Okay? Now, what we're going to be talking about today are two types of transformation. They're called translations and reflections. Translations and reflections. Let's talk about translations. By definition, a translation is any shift. It's any shift, left or right, up or down. That's it. Okay? What we're going to be doing is taking the equations that we learned within this past chapter and doing that to these equations. We're going to be shifting it up or down or left and right. And we're going to be creating rules on what it means. So say we had our f of x here. Here's our equation, y equals f of x. Here's our equation. If I shift it to the left or to the right, what happens is I'm changing the x value, right? I'm changing the input. I'm not changing anything up or down. I'm not changing the y value. All I'm doing is just shifting those coordinates left and right, which is only changing the input value. So what's going to happen here is you're going to see this type of notation where I have f and then inside the parentheses an x plus or minus. If it's inside the parentheses, it's a shift left or right. And I'm going to write that underneath here. Inside equals left or right. Outside is up or down. If I shift it up or down, what's happening is I'm adding or subtracting to the outside of the function. So if I have like f of x plus 5, that's a shift up 5. If I've got f of x minus 2, that's a shift down 2. If I've got an f of x plus 7, up 7, where I'm just adding or subtracting, I'm tacking on a plus or minus to the end of an equation. F of x plus 30 is an up 30. Now, if I were to put it inside parentheses, that's left or right. Left and right is really weird because I have to actually take the opposite. Like if I have f of x minus 7, because it's inside parentheses, you would say, okay, this has got to be left or right. What does your intuition say about minus 7? What do you think should happen with a minus 7? Left 7. It's actually a right 7. Isn't that weird? It's actually the opposite of what our intuition says should happen. This is actually a right 7. The reason that that's happening is because in our initial equation, it was f of x minus h. So the h value is actually a positive 7. That's why it's going to the right. So thinking now, well, what happens if this is like an f of x plus 9? What do you think is going to happen now? I mean, our intuition might say, oh, plus means right. But what is actually going to happen with the equation? It's going to go left. It's going to go left 9. Now, up and down, straightforward. There's no weird things going on. F of x plus 20. What do you think happens? Up 20. F of x minus 10, down 10. Okay? Let's take a look at some examples. So for all of these examples, I'm going to give you an old equation, and then I'm going to give you a notation that will tell you what to do with it. Like here. I'm saying our old equation was f of x is equal to 3x minus 4. I'm going to take that equation, my old f of x, I'm going to transform it, and when I transform it, I'm going to turn f of x into g of x. It's going to change, so let's call it a new name. So f of x is going to turn into g of x. Now look at the rule for g of x. What is that telling me to do?
Up 3.
Up 3. Is it inside or outside of the parentheses? Oh, you didn't? I said left 3. You sure? Yeah, you sure? Are you sure? This is going to go up 3. Now, we could go and graph it and actually physically move the points up 3 units, but that doesn't tell us what's going on with our equation. Here's how to work with the equation. We said that g of x is going to be f of x plus 3. What is f of x? What is f of x?
3x minus 4.
3x minus 4. So now g of x is going to be f of x plus 3. So yeah, up and down is literally just tacking on a plus or minus at the end of the equation. So g of x is 3x minus 1. There's my new equation. This question is asking me 2 things. It's saying, describe for me in words what the transformation is. You just got to tell me up, down, left, or right, and then a number. And now, give me the equation. Here's what I would like to do. I'm going to graph old in green and new in blue. I hesitate to tell you to graph. I would strongly recommend you graph both functions, but use colors, just like I'm doing here. Okay? I would strongly encourage you to graph using colors. If you're not graphing using colors, just graph the new. Just graph the g of x. So like f of x is 3x minus 4. So I'm going to put this in green. Y-intercept of negative 4, slope of 3. I'm moving past. I'm just assuming that we know how to do that now. So y-intercept of negative 4, slope of 3. Rise 3, run 1. Rise 3, run 1. Rise 3, run 1. And so on. So there's my line. You know, visually, without even graphing g of x yet, wouldn't I just like take this line and go 1, 2, 3, right? Wouldn't I do that? So let's kind of verify that that's going to happen by graphing our new line. Our new line has a y-intercept of negative 1, slope of 3. Do we see the same line just shifted up 3 units? Yeah. I know the steepness might throw you off a little bit, but I would ask you to take a look at the y-intercepts. Take a look at the y-intercepts. Did that go up 3 units? Yes. Yeah.
I'm kind of confused. Like, how did you get those lines again? Like,
the mx plus b. I took the b value, and then I did the slope. 3 is my slope, so up 3 over 1. And then I did the same thing here, mx plus b. Y-intercept is negative 1, slope of 3. That make sense?
Yeah.
Okay. And you could label them like here. This was f of x, so I'm going to label that with an f, and label this with a g. Okay. If you weren't using colors and you really wanted to graph both of them to see the transformation, just write a little letter next to it. Let's do that a couple more times. All right, so g of x is f of x plus 3. Notice that I changed my old. My old is now 2x minus 1. And now my transformation is an f of x plus 3. What is that telling me to do? What'd you say? Left 3. Left 3. Inside parentheses tells me left or right. And now our intuition might say go right 3. Counterintuitive. That's actually left 3. So we would say that this is a left 3. Now, whenever I have a left or right, do you see how I change what's inside parentheses here? Whenever you have a left or right, if you change what's inside the parentheses here, you change what's inside the function. Like, remember when I said this? This was on our last test. What is that notation telling you to do with 2? Plug it in. Plug 2 into the equation, right? Just like if I said this was f of negative 5, that's telling you to take negative 5 and put it into the equation. So if I tell you find f of x plus 3, what does that tell you to do with x plus 3? plug it into the equation. So g of x is going to be 2 times not x minus 1, but 2 times x plus 3 minus 1. I remove x, and in its place, my new input is x plus 3. Now from this point, I just simplify. Distribute with the 2, and I combine like terms. Okay, let's graph old and new. Old is 2x minus 1, so y-intercept of -1 and a slope of 2. Question?
Are we docked points on the homework if we graph both?
No. Definitely graph the new. No matter what, graph the new. But I would strongly encourage you to graph both.
Okay.
So y-intercept is -1, slope, or sorry, yeah, -1, slope of 2. I'm graphing my old. So here's my old. That's f. Now, remember that for g, I should see everything pushed to the left 3 units. Let's graph it. +5 is my y-intercept, and a slope of 2. And I could go down to left 1. Do I see a shift left 3 units? Yeah, take a look here. Look at these coordinates. Do you see how each of these coordinates are being pushed left 3 units? Okay. Questions about that? Let's do that a couple more times. Let's try this one. 35?
Yeah, 35.
Yeah. You done, Joe? Yeah. Do I have to write it fast? Yeah. Joe. 2, 5, at 10, 28, loud, early. Thank you, sir. All right. Okay, what is this notation telling me to do? Nathan?
It's telling you that x is equal to
Like shift, what type of shift? Up, left, down, right, crossways?
down 3.
Down 3. Okay, that's part of my answer. The next part of my answer is giving the equation that shows us down 3. Okay, g of x is f of x minus 3. Well, f of x was 1/3 x plus 1. Tack on a minus 3. So g of x is 1/3 x minus 2. +1 minus 3. Yeah, just simplify. Okay? So now my old has a y-intercept of 1 and a slope of 1/3. Okay, so there's my old. There's f. And now let's graph g. Y-intercept of -2 and a slope of 1/3. Do I see a shift of down 3 units for g? Okay. Yeah.
I'm gonna go down like 2 units and minus 2.
Be careful there. I started at a +1. So I was already 1 unit above the x-axis. You're right, I go down 2 units from the origin. But from my old function, I do go down a total of 3 units. Yeah, that could kind of throw some people off there. His question was, wait a second, I only see a -2 at the end. Wasn't I supposed to go down 3? But remember, I started at +1. Okay, flip it over onto the back. We're going to talk about the reflections real quick. Honestly, it's a lot of the same stuff. You just got to learn the rule. A reflection across the x-axis is a negative on the outside. This you just got to memorize. Reflection across the x-axis is a negative on the outside. Reflection across the y-axis is a negative on the inside. Okay? Reflection across the x-axis is negative on the outside. Reflection across the y-axis is negative on the inside. So when I go to reflect, same type of thing here. Just reading from above, what is that notation telling us? What is a negative f of x? X. Reflection across the x-axis. I'm going to say ref over x-axis. Okay, so what is that telling us to do in our equation? That's telling us that g of x is negative f of x. Okay, negative, what's f of x?
3x plus 1.
3x plus 1. So it's the opposite of 3x plus 1. Negative 3x minus 1, yeah. Okay, well, let's graph it. Our original was positive 1 with a slope of 3. Our new is the y-intercept of negative 1 with a slope of negative 3. Did it truly get reflected over the x-axis? Yeah. It got reflected over the x-axis. If I took a mirror image on the red line with the mirror sitting on the x-axis, it would reflect over.
Pardon the interruption. We do have one announcement. Attention middle school jazz band members. There is no middle school jazz band after school today. Middle school band members, no middle school jazz band after school today. See you on Monday. Thank you.
Okay, I know I'm running out of time, but negative on the inside is a reflection over the y-axis, and all I do, g of x would be plugging in negative x into the equation, because that's the notation telling me. I take out x and I plug in negative x. The only thing that happens with this one is it goes positive. So g of x would have been positive 2x plus 1. So a reflection over the x-axis changes both slope and intercept, where a reflection across the y-axis just changes the slope. Okay? All right. So long, everybody. Playing along at home as well.